Welcome to tutorial number 160. This tutorial will be a theoretical tutorial, but it will be important tutorial to understand the logics behind the sheet metal bendings in order to get an accurate sheet metal's dimensions. In this tutorial, we will talk about the sheet metal trees and where to locate the bend allowance menu, and then talk about different materials, calculating the K factor, and see general K factor values. And then at the end of this tutorial, we will see some programs that calculate the K factor. So here we have a new part file. Start with the top plane and draw a V shape. I'll define it here and give it some dimension. And here give it a symmetry relation. And now make sheet metal beam from this V shape by the base flange. And here give it a length of 150. As you remember, we talked in the early tutorials that we will talk later about the bend allowance over here. So we will discuss this menu now. So if you open the bend allowance, you will find many methods to calculate the bend allowance. You have the bend table, which will be the topic of the next lecture, and the K factor, and then the bend allowance, which is a longer equation that includes the K factor. We will look at the formula of bend allowance and then the bend deduction and bend calculation. The last two, they are mostly based on experience, and so we will discuss more the first three options, and then in the tutorial after the next one we will talk about the gauge table, where you can combine the bend table and K factor, a saving time method. So now for now pick a K factor, and as you remember in the previous tutorial we said this will be a stainless steel sheet, and we assign 0.4 K factor, and we will see how we came to this value. And then when you are done, click OK. We said in the tree you will get the cut list and the sheet metal and the base flange, and if you want to get back to the theoretical values, you should edit the sheet metal over here, and here you can find or adjust the bend allowance, but you cannot find it in the base flange. The reason for that, we said it considered the whole work on the same type of sheet metal or one single sheet metal part. And let's say just specify a material to make it clear that we are dealing with stainless steel sheet. Why there is a bend allowance? The reason for that, there are different materials, and as we said, when you bend a sheet of aluminum, will not give you the same dimension as bending a sheet of steel, and so on with the copper. Also, the type of press you are using. If you have a press with a bigger bending radius, also that will affect, for example, the K factor. The K factor is the ratio between the neutral line and the thickness of the sheet metal. As we can see here, here we have the neutral line, and here we have the thickness is T over there. The place of the neutral line can be changed depending on the bend radius and the bend angle. Now again go to the sheet metal and let's talk about the next, the bend allowance. The bend allowance is kind of more accurate way because it used the complete formula, which we can see it over here. The bend allowance is by multiply with the radius, the bend radius plus kt over 180. So this is the formula of the bend allowance. In one of the next tutorial, we will talk about the gauge tables, a popular method in the industries which combine both methods. Here I return to the key factor, click OK. Now you may think it is complicated process, but it is not because the values are already calculated for the most used sheets. There are bending tables we will talk about in the next tutorial, and also there are even a faster way called gauge tables will be also the topic of the tutorial after the next. And here if you go to the Wikipedia, you can read more to understand this topic, and you will notice it is, so I recommend you to read this article about bending. It will give you a wider understanding about the sheet metal bendings. And here you will see the types. Also you have the punch, and at the end you'll see more detail about calculating the K factor and bend allowance, as we said. And then you have a general table that you may use for the most standard sheet metals of aluminiums and steel. And here the value of the K factor, which you can pick according to the radius, bend radius. For example, we have in our example, this back to the values over there, we have the bend radius 0.7 and thickness is 1 millimeter. Material is steel. You can find the value will be 0.4. And also as you notice here, when the bend radius is increasing compared to the thickness, the value of K factor is increasing as well, and the hardness of the material will also affect the K factor. As we know, the steel is harder than aluminium. Here is an example for a sheet metal industry, example for a bending press, and they have also their app for calculating the bend and K factors. And you can start it here, and if you go to the bend deduction, you can see very easily the values over there and calculate the K factor. As you remember, we used stainless steel in our example, and we made the thickness 1 millimeter and the A side and the angle 75, the A side 126 and 126. Then calculate and here you will see the value of K factor. It is close zero point 0.4. If you remember, we said if you increase the bending radius, that will increase the K factor. Here you have the bending radius. Let's make it 2 millimeter, and you will notice the K factor became 0.5 and so on. If you make it 0.4 or more, it will be 0.6. Now return to our sheet metal beam and go to the sheet metal to modify the values. Here you can change it according to the website, or you can keep it 0.4. I'll make it 38, and you know from where I bring the 0.38. Click OK.